Class example 4.22. Given the function f of x is equal to 3x plus 5, determine the indicated characteristics of the function y is equal to the square root of f of x. Use an algebraic approach and do not graph. Okay, so let's determine the domain of y is equal to the square root of f of x. So remember that y is equal to the square root of f of x is only going to be defined where f of x is greater than or equal to 0. So you just can't square root a negative. So in our case, we can think about this. If we have y is equal to the square root of 3x plus 5, well, this part underneath can't equal, or it has to be greater than or equal to 0, right? It can't be a negative number. So we would end up saying 3x plus 5 has to be greater than or equal to 0. And that's kind of our starting point for this. So yeah, as a recap, we need to think about where is 3x plus 5 greater than 0. So even with the inequality, remember that you can do algebra just like you normally would if this was an equal sign. So subtract 5 from both sides and then divide by 3. So x needs to be greater than or equal to negative 5 over 3. Now let's determine the coordinates of any invariant points for the graph of f of x and the square root of f of x. So remember that the invariant points occur where the values of f of x, where the square rooting returns the same value, right? So that's going to occur when we have the square root of 0, right? Because the square root of 0 is 0, and the square root of 1, because the square root of 1 is 1. So to answer this question, we need to think, where is 3x plus 5 equal to 0? And on that note, you could also think of it as, where is the square root of 3x plus 5 equal to 0? Because it'll actually be the same thing, right? That's the whole point, that your x values would be the same for both of those situations. But it'll be easier just to ignore the square root when we're solving these. And also, where is 3x plus 5 equal to 1? And the square root of 3x plus 5 equal to 1. So if we solve this just using simple algebra, subtract 5 from both sides, divide by 3, we get x would be equal to negative 5 over 3. Subtract 5 from both sides, so 1 minus 5 is negative 4. And then divide both sides by 3, we get x is also equal to negative 4 over 3.